We live under a misconception so fundamental that we've stopped noticing it. For 340 years, physics has carried a misreading so persistent that we've made it into dogma. We've blamed Newton for it. We've fought Einstein against it. We've built quantum mechanics around it. The misconception is this: time is a substance. Time is absolute. Time flows independently, like a river that exists whether or not anything moves in it. Newton gets the blame, but Newton never said that. One word changes everything. In Newton's immortal Principia, the mathematical principles of natural philosophy, he wrote a line in the scholium that begins the work: "Absolute, true and mathematical time, of itself and from its own nature, flows equably without relation to anything external." Between Samuel Clarke's careful rephrasing of this stance later on and our own general human propensity for satisficing, accepting concepts based on authority rather than doing the onerous work of checking premises, which is not derogatory but simply thermodynamic law, today we have a hard-baked concept of time as being absolutely independent. But look closer. There is a single word that changes everything: mathematical. Mathematics is intrinsically true and absolute because it is an idealization, a quantitative language of precise, reproducible form. So what is Newton actually saying in this sentence? Is he describing a physical, independent container? No, he is describing a mathematical time. Please note that as we discuss Newton in the framework of modern natural philosophy, of thermodynamic process philosophy, I am naturalizing the deep, divine sourcing that was Newton's own permeating view of everything around him, including his own natural philosophy work and its public culmination, the Principia. We are not equating, we are naturalizing Newton's divinity. Yet nor are we dismissing the divinity, for what lies beyond our epistemological barriers is exactly that: the unknowable. Imagine a thought experiment. Imagine a universe where entropy never increases, where nothing ever changes, where every configuration remains exactly as it is forever. No energy redistribution, no thermal gradients, no transformation whatsoever. The second law of thermodynamics is suspended. Delta S equals 0 always. Now ask yourself a simple question. Does time exist in that universe? Think about what time actually is before you answer. What is time? We say it's what clocks measure. But what do clocks do? They oscillate, tick-tock, tick-tock. Each tick is a change, a transition from state A to state B. Each tick requires a clock hand to move, a pendulum to swing, an atom to vibrate. Change requires energy. Energy redistribution is entropy. If delta S equals 0, if no change is possible, then no clock can operate. No clock, no periodicity, no way to measure passage. Can you even define time in such a universe? You cannot. Because time only has meaning through change, and change only happens when something moves, and motion only happens when energy reorganizes itself, and that reorganization is entropy production. Remove entropy production, and time becomes a meaningless abstraction. Now try the reverse. Could consciousness exist in that frozen universe? In thermodynamic process philosophy, consciousness is identity differentiation, a process. A mind integrates prehensions across time. It accumulates experiences, remembers the past, anticipates the future. It has temporal depth. But if nothing changes, if delta S equals 0, then no prehension is possible. No experience can transition from one moment to the next. No consciousness can accumulate itself. Remove entropy production, and consciousness literally cannot exist. Here is my reductio in its cleanest form. Premise 1. Time is that which clocks measure. Premise 2. Clocks require periodic change, entropy production. Premise 3. Remove entropy, thus remove change, thus clocks cannot operate. Conclusion. Remove entropy and time becomes meaningless. Premise 4. If a concept becomes meaningless when a phenomenon is removed, then that concept is not separable from that phenomenon. Conclusion. Time is not separable from entropy. Therefore, time is entropy production as ontological identity. This is not speculation. This is definitional logic. It's Parmenidean reasoning. If you remove entropy and time simultaneously loses all operational meaning, then time was never distinct from entropy in the first place. They are the same phenomenon described in two languages. One language is thermodynamic. Entropy increases. The other language is phenomenological. Time passes. The astonishing thing is not that this is true. The astonishing thing is that physics has never formalized this as an ontological identity. We say time has an arrow, entropy increases. We say time emerges from entropy. But we don't say the obvious thing. Time's engine is entropy production. Why not? Because 340 years ago, someone misread Newton. Or rather, and this is the subtler truth, someone read Newton very carefully, understood his position precisely, and then rephrased it in a way that obscured what he actually believed. In 1623, Galileo wrote something that became the manifesto of the entire scientific revolution. The book of nature is written in the language of mathematics. Its characters are triangles, circles, and other geometric figures. Without these, it is impossible for humans to understand a single word of it. This wasn't poetry. This was a metaphysical claim. In the Essaya, Galileo was drawing a hard line between what he called primary qualities, shapes, numbers, motion, and secondary qualities, colors, tastes, warmth. Galileo was saying that what we perceive with our senses is computationally irreducible. It is qualitative. It is loaded with what we might call irreducible fuzziness. To describe the feeling of warmth to another person involves a massive amount of qualitative uncertainty. You never know if they truly grasp your fully intended meaning. But the mathematics? The mathematics is reproducible. That was the breakthrough. If I give you a triangle, or a velocity vector, or an equation, I have stripped away the qualitative uncertainty of consciousness. I have handed you a piece of information that you can reproduce exactly, without having to guess at my subjective experience. Galileo idealized the world into mathematics not to ignore reality, but to create a language that could bypass the fuzziness of human perception. Galileo didn't just believe this. He proved it experimentally. He rolled balls down inclined planes and discovered something astonishing. The distance fallen is proportional to the square of the time elapsed. This relationship, this mathematical relationship, is the true nature of falling. The sensation of falling is just what this mathematical law feels like. Now, Galileo gave us the kinematics. He answered, how much and how fast. He gave us the mathematical language for describing motion. Newton took Galileo's kinematics and asked a deeper question. Why? Why is distance proportional to time squared? What causes objects to move? And with that question, Newton inverted the hierarchy. If Galileo mathematized motion, Newton mathematized the causes of motion. He created dynamics. And in doing so, Newton did something revolutionary but in the same spirit as Galileo. He unified the earthly and the celestial. Galileo had shown that the moon isn't so different from Earth. It reflects light. It has surface features. But Newton did something deeper. He proved mathematically that the apple falling from a tree and the moon orbiting Earth are the same phenomenon, the same mathematical event. One equation, one law of gravitation. Force equals g times the mass of the first object, m1, times the mass of the second object, m2, divided by the distance between their centers, squared. This was Newton's inheritance from Galileo. Find the mathematical unity beneath apparent diversity. But here's what often gets missed. Newton was not a pure theorist. He was an experimentalist in Galileo's tradition. Galileo used a telescope to see what was invisible. Newton used a prism to see what was hidden in plain light. In optics, Newton performed dozens of careful, detailed experiments. He split light into its component colors. He recombined them. He studied refraction, reflection, diffraction, all experimentally. Why? Because Newton had learned, as Galileo did, that the only way to access truth is to ask nature, not to consult ancient books. Aristotle said light was indivisible and colored by the medium it passed through. Newton put a prism in a beam of sunlight and showed the light itself was composed of all colors. Data first, theory second, authority nowhere. This is the experimental flavor they shared. Neither man was content with speculation. Both demanded measurement. Both Galileo and Newton were doing something subtle and often unnoticed. They were inventing idealized worlds to find the truth about the real world. Galileo's frictionless plane is a perfect example. In reality, rolling balls experience friction. The surface is never perfectly smooth. Air resistance acts. 1,000 minor imperfections affect the trajectory. But Galileo asked, what if we could ignore all that? What if we imagined a plane with zero friction? In that idealized world, the mathematical law becomes pure, unobstructed, distance proportional to time squared without interference. And here's the brilliant part. That idealized world reveals the truth about the real world. The real world also obeys this time-to-distance proportion, but friction hides it. The ideal frictionless world shows you what's really going on beneath the noise. Newton did the exact same thing, with time. Listen carefully to Newton's words from the Principia. Absolute, true, and mathematical time, of itself, and from its own nature, flows equably, without relation to anything external. What is he describing? He's describing an idealized time. A time with no friction. A time that flows perfectly uniformly. Why? So he could do the mathematics. Just as Galileo idealized away friction to reveal the pure law of motion, Newton idealized time itself. Mathematical time is perfect, uniform, frictionless. It's the t parameter in his equations. It's the backdrop against which he could calculate F equals ma without having to account for the actual messiness of how time is experienced. But, and this is critical, Newton knew this was an idealization. Immediately after defining absolute true mathematical time, he says, relative, apparent, and common time is some sensible and external measure of duration by the means of motion, which is commonly used instead of true time. He's making the same distinction Galileo made. The idealized world, mathematical time, reveals the truth. The real world, common time measured by motion, is what we actually experience, distorted by the friction of how thermodynamic processes actually work. This is Newton being Galileo's heir. He's using Galileo's method. Create an idealized mathematical world, do your calculations, then return to the real world with the truth you've discovered. Galileo: how do I find the law of falling? Imagine a frictionless plane. Newton: how do I find the laws of motion? Imagine perfectly uniform time. Both are doing the same thing. Both are using mathematical idealization as a tool for discovering physical truth. Here's what the standard reading misses. Newton wasn't a secular physicist in the modern sense. He was a natural philosopher in an older, deeper tradition. And that tradition carried weight that most of us have forgotten. When Newton published the Principia in 1687, he presented a face to the world, the natural philosopher as mathematician, as experimentalist, as the heir to Galileo. This was the public Newton. The Newton the Royal Society recognized, the Newton whose mathematics worked. But there was another Newton. In the decades around the Principia's publication, Newton spent more time on alchemy, theology, and ancient history than he spent on physics. We have over 1 million words of alchemical manuscripts in Newton's hand, not as a hobby, as a core practice. He translated the Emerald Tablet of Hermes Trismegistus, the foundational text of Hermetic wisdom, carefully, extensively, multiple times. He studied the Temple of Solomon, trying to decode its mathematical proportions as revealing divine architecture. He wrote lengthy theological treatises arguing against the Trinity, positioning himself within an ancient current of thought, stretching back through medieval scholars and Renaissance mystics to the Hermetic philosophers of Egypt and Greece. This was not the work of a man compartmentalizing his life into science and private belief. This was a man pursuing a unified vision. For Newton, mathematics wasn't a value-neutral tool. Mathematics was a sacred language. The book of nature written in mathematics wasn't just poetic phrasing, it was a literal claim about divine revelation. Newton believed he was decoding God's self-manifestation. He believed in Prisca Sapientia, the ancient wisdom that had survived from antiquity, hidden and encoded in texts that required careful, initiated study to understand. This context changes everything about how we read his famous phrase, absolute, true, and mathematical time. Because the word mathematical carries different weight now. It's not just idealized in a pragmatic sense, it's mathematical as opposed to sensible, as opposed to what the bodily senses grasp directly. In the ancient philosophical tradition Newton was recovering, in the Platonic and Hermetic schools, there was a fundamental distinction between what the senses perceive, particular, bounded, temporary, and what the intellect grasps, universal, infinite, eternal. The senses show you changing things. The intellect shows you the principles by which things change. When Newton says mathematical time, he's pointing to time as understood by the intellect, not as perceived by the senses. And that distinction is crucial, because it means that mathematical time isn't merely a pragmatic tool for calculation. It's time as it exists in the realm of principles, of pure form, of divine architecture. It's a very different claim than I'm idealizing for calculation purposes. It's a claim about accessing a higher order of reality. But Newton left us a gift. In the early 1690s, Newton was contemplating revisions to the Principia. In his unpublished manuscript, Tempus et Locus, not published until 1978 by J.E. Maguire, Newton is much more explicit about what he actually meant. The opening begins, "Time and place are common affections of all things, without which nothing whatsoever can exist. All things are in time as regards duration of existence, and what is never and nowhere is not in the nature of things." The second section continues, "Time and place in themselves do not fall under the senses, but are measured by means of sensible things, such as magnitudes of bodies, their positions, local motions, and any changes uniformly made." And then, crucially, the third section, "For the duration of a thing is not its flow or any change, but permanence and immutability in flowing time. All things endure insofar as they remain the same at any time. Its substance does not flow, and is not changed with respect to before and after, but always remains the same." Stop here. Read that again. Duration is not its flow or any change, but permanence and immutability in flowing time. This is the finger pointing. This is what Newton actually believed, stated plainly in his unpublished work. Newton is explicitly saying that duration, which is what time ontologically is, equals things existing and changing. Time, as what we measure, equals duration as revealed by motion. They're not two substances, but one phenomenon described two ways. Duration is the underlying reality, things persisting while flux occurs around them. Time is what we observe when we measure that duration through motion. Motion reveals duration. And in modern viewing, motion is entropy production. Therefore, as thermodynamic process philosophy would state, time is entropy production revealed by observation. Newton understood that time was fundamentally tied to motion, to change, to physical process. But here's the deeper layer that Newton's temper set locus reveals. Newton isn't simply saying time equals change. He's saying something more subtle. Time has a dual structure. On one hand, flux, change, motion, entropy production. The river flows, energy redistributes, things transform. But on the other hand, duration, permanence, identity persisting through change. The substance remains the same while flux flows around it. These aren't contradictory, they're complementary. From the perspective of pure entropy, time is flux itself, the engine, the direction of change. This is what thermodynamics discovered in the 1850s. Entropy increases, therefore time has an arrow. But from the perspective of identity, time is resistance to flux. Duration is how long something maintains itself against dissolution. Again, bringing this concept forward through the centuries, time is how long identity persists in the face of entropy production. Both are true simultaneously. Entropy is the motion, the direction, the engine. Duration is the meaning, the persistence of identity against thermodynamic dissolution. Remove entropy production, and you get a frozen universe with no time. Nothing changes. Remove identity persistence, and you get an undifferentiated plasma with no meaningful time either, no structure to measure duration against. Time requires both. Newton's temper set locus also makes something else explicit. In section 4, Newton addresses God directly. Space, by reason of its eternity and infinity, will neither be God, nor wise, nor powerful, but will merely be increased in duration and magnitude. Whereas God, by reason of the eternity and infinity of his space, that is, by reason of his eternal omnipresence, will be rendered the most perfect being. Notice that phrasing, his space. Newton is not talking about space as an independent substance. He's talking about space as God's omnipresence manifested. Similarly with time and duration, God's eternal existence, his permanence, his unchanging nature, his infinite persistence. This is what true time actually is. Duration is what time ontologically is, and duration at its deepest level is God's own eternal persistence. This is what Newton actually believed. In an earlier unpublished manuscript called De Gravitatione, written in the 1680s but not published until 1962, Newton was even more explicit about this metaphysical grounding. He states, "Space is of eternal duration and immutable nature, because it is an emanative effect of eternal and immutable being." Emanative effect, not created, not produced, not constructed, but emanating, flowing out of, overflowing from, the necessary consequence of divine existence. This is the language of Neoplatonic philosophy. It's the language of Hermetic philosophy. Space and time aren't things God made. They're manifestations of what God is. God exists necessarily and eternally. Therefore, space and time necessarily and eternally exist as the forms in which that divine existence manifests. Newton is recovering an ancient philosophical tradition here, the tradition of divine emanation, and applying it to the metaphysics of space and time. This is natural philosophy in the deepest sense, the attempt to read the nature of reality from the nature of divine being. We have spent 340 years arguing over a typo. We thought Newton gave us a clockwork universe that exists in a cold, empty box called time. But the manuscripts, De Gravitatione, Tempus et Locus, reveal a different architect. Newton didn't build a box, he described a relationship. There is duration, the persistence of existence, and there is flux, the action of change. When we write T in an equation, we are using a mathematical shorthand for the persistence. But when we live our lives, we are experiencing the flux. We have been mistaking the bookkeeping for the event. The great reconstruction of physics starts here, by admitting that time is not the stage on which the play occurs. Time is the play itself. Now we arrive at the most fascinating historical moment. It's spring of 1715. Leibniz is arguing that time is relational, that time is nothing but the order of successive events, dependent entirely on things existing and changing. Newton is elderly, ill, and doesn't answer directly. Instead, he enlists his defender, Samuel Clarke, a rising theologian and natural philosopher, brilliant and literal-minded, to respond to Leibniz's philosophical attack. This is dangerous to Newton's system because it seems to make time dependent on the created world. Samuel Clarke responds on Newton's behalf, and in the Leibniz-Clarke correspondence of 1715 to 1716, Clarke writes something that reveals everything. Also, that time is not merely the order of things succeeding each other is evident, because the quantity of time may be greater or less, that order continue the same. If no creatures existed, the ubiquity of God and the continuance of his existence would make space and duration to be exactly the same as they are now. Think on that phrasing carefully. If no creatures existed, the ubiquity of God and the continuance of his existence would make space and duration. Clarke is saying, space equals consequence of God's omnipresence. Duration equals consequence of God's continuing to exist. This is exactly what Newton's unpublished manuscripts say, but Clarke doesn't use the dangerous word. He doesn't say emanation. He doesn't say space is God's omnipresence. He says, would make space to be, passive voice, careful phrasing. And Clarke definitely doesn't say sacred or divine attribute. He phrases it in a way that sounds like space and time are independent substances that happen to exist because God exists. Why did Clarke do this? Because Clarke knew what Newton actually believed. Clarke was Newton's inner circle. Clarke shared Newton's anti-Trinitarian theology, his rejection of the Trinity doctrine in favor of a more ancient, simpler monotheism. Clarke was one of the few people in England who understood Newton's radical theological position. And Clarke knew that if he stated Newton's true position explicitly, that space and time are emanations of divine being, that they're manifestations of God's omnipresence and eternal existence, it would expose Newton to charges of heresy. It would sound like pantheism. It would endanger both of them. So Clarke did something strategically brilliant. He defended Newton by rephrasing Newton's position in language that sounded orthodox, space and time as independent substances, while technically saying what Newton believed, that they exist because of God's ubiquity and continuance. It's a careful encoding, a protective move by someone who understood both Newton's true position and the political danger it represented. After Newton's death, Clarke and others controlled what Newton's papers revealed to the world, and, crucially, they suppressed or hid the most radical of them. Newton's theological papers, his alchemical manuscripts, his Tempus et Locus, these remained unpublished for centuries. What the world got was a Newton filtered through Clarke's careful rephrasing, a Newton who sounded like an orthodox mechanist, a mathematician who idealized time for pragmatic purposes, a natural philosopher safe enough to build modern science upon. But not the real Newton, not the natural philosopher who believed in divine emanation, who studied alchemy and ancient theology, who saw mathematics as sacred language and nature as God's self-revelation. The tragedy is that this filtering worked too well. For 340 years, physics read Newton through Clarke's careful encoding. Historians read Clarke's defense and concluded that Newton believed in time as an independent absolute substance. And when that interpretation created problems later, when Einstein showed time was relative, when quantum mechanics couldn't figure out how to quantize time, when physicists spoke of the problem of time, nobody looked back and checked what Newton actually said. They just assumed Clarke had gotten it right. Clarke had been protecting Newton from heresy charges, but in protecting him, he'd accidentally given physics a Newton that Newton himself would not have recognized. So when you look at the famous passage from the Principia, absolute, true, and mathematical time, of itself and from its own nature, flows equably without relation to anything external. You should now understand what Newton was actually saying. He was saying in modern terms, in my equations, I use a perfectly uniform time parameter, mathematical time, so I can do calculus without having to account for the real-world complexity. Just as Galileo said, I need a frictionless plane to see the law. Newton said, I need perfectly uniform time to see the law. But, and this is the deeper level, mathematical also means accessing a higher order of understanding. Time as grasped by the intellect, not merely perceived by the senses. Time as it exists in the realm of divine principles. And absolute, true, means that beneath common time, the messy, entangled temporal flow of the physical world, there is an ultimate ground, God's eternal duration itself. Duration is permanence in flowing time, or to thermodynamically rephrase, entropy is the flowing, duration is the permanence. Remove either, and meaningful time disappears. Newton's vision naturalized time as the intersection of entropy, divine flux, and identity, divine permanence. Physics discovered in pieces, Newton understood as unified. From thermodynamics in the 1850s, it was entropy increases, time has an arrow. Physics recovered the flux side. From relativity, 1905, arises time depends on motion. Time is relative to reference frame. Physics confirmed Newton's relational intuition. From quantum mechanics, 1926 to present, time is an external parameter, not a dynamical variable. Decoherence, entropy production, is what makes quantum superposition collapse. Physics is using Newton's mathematical time correctly, but hasn't formalized what's actually happening. The problem of time in quantum mechanics, why time is special, why it's not quantized, exists because physics confused two different things. Mathematical time, t parameter in equations, what Newton called absolute, true, and mathematical. Physical time, entropy production measured, what Newton called common time. These are two languages for one phenomenon. Mathematical time is the perspective of the infinite that cannot be imagined but understood, as Newton wrote in De Gravitatione. A realm of time as principle, as form, as independent of being perceived, or in fact of being perceivable, to paraphrase J.E. Maguire in his commentary to his translation of Tempus et Locus. Physical time is the perspective of the sensible realm, time as we measure it through motion and change. Newton understood both simultaneously. That's why his system works. That's why idealized mathematical time, applied to real physical systems, generates predictions that match observations so precisely. Because mathematical time isn't separate from physical reality, it's the natural philosophical principle of physical reality. The form in which for Newton was divine permanence manifests as sensible change. When we lost natural philosophy as an epistemological framework, we lost that important distinction of natural philosophical principles. Let us trace the lineage in full, a lineage that started with a revolution and ended in a misunderstanding. It begins in the early 1600s with Galileo. He was the first to really argue that the book of nature is written in the language of mathematics. His trick was simple but profound. If you want to find the truth, you have to ignore the noise. You imagine a world of frictionless planes and perfect spheres. You measure first, and you let the speculation follow the data. By 1687, Isaac Newton takes that Galilean torch and runs with it. He decides to mathematize not just motion, but the causes of motion. To do it, he employs a new, ultimate idealization: mathematical time. But, and this is the part we missed, he explicitly warns us that this isn't the common time we measure with our clocks and our senses. In his private heart, he knew that these mathematical coordinates were just manifestations of a deeper, divine persistence. But then, the pivot. In 1715, Samuel Clerk enters a legendary debate with Leibniz. Clerk is Newton's bulldog, but he's in a tight spot. To protect Newton from charges of heresy, the idea that God and space are too closely linked, Clerk starts using strategic language. He stops talking about divine emanation and starts talking about independent substances. He builds a safe version of Newtonianism that hides the radical truth. And for 300 years, that encoded version is the only Newton we were allowed to see. By the mid-1800s, thermodynamics arrives. We discover entropy and the arrow of time. We basically rediscover what Newton had written in his private papers, that time is change-dependent. But we don't make the final leap. We don't formalize the identity. Then comes Einstein. In 1905, he proves that time is relative to motion. He's actually formalizing Newton's original relational insight, the common time Newton wrote about. But Einstein doesn't know that. He thinks he's refuting Newton when in reality he's recovering him. Even today, quantum mechanics is stuck in this same rift. It uses mathematical time as an external parameter, which is the correct way to use the tool, but it struggles with the problem of time because it confuses the mathematical map for the physical territory. It sees the math and wonders where the flow went. And that brings us to today, to a perspective that finally recognizes the identity that time is entropy production. It's a dual structure, the flux of change meeting the permanence of existence. By recognizing this, we aren't just inventing something new, we're completing the program Galileo and Newton started. We're finally seeing past Clerk's strategic curtain to the vision Newton held all along. The good news. Newton's actual position is recoverable. It's all there in his unpublished manuscripts. His dual ontology integrated into thermodynamic process philosophy as entropy, flux, change, divine action, plus duration, permanence, identity, divine being. Time requires both. Remove one and meaningful time disappears. Understand both and you finally grasp why Newton's idealized mathematics works so perfectly on the physical world. It works because the idealization and the physical reality are two perspectives on the same structure. The idealization as statistically emerging symmetry, the conditions needed for duration, which is the physical reality. From Newton's structure of divine emanation, an infinite permanence manifesting as infinite change, as eternity flowing into time, we now have being becoming. Identity revealing itself through flux. This is Newton's vision naturalized without losing his genius, and all this at last recoverable from his own words.